Hello everyone and welcome to a new episode of All Things IDA. In today's episode I'm going to be introducing actions and action handlers. These are basic components that will enable us in the future to add some UI components to IDA, for example, new menu items, pop-up menu items, toolbar actions, and even just plain hotkeys. So with this basic knowledge, we'll be able to understand actions, how to retrieve all the actions, register, unregister actions, and so on. And in the future episodes, we'll be able then to use that knowledge to apply it and add menu items and so on. With that, let's get started. Before we jump into actions and action handlers programmatically, let's first look at actions just using the UI to approach it from what we see all the way down to the programmatic level. So actions, one way to see the actions, for example, if we go to the options and select shortcuts, these shortcuts allow us to configure the hotkeys of registered actions, for example. So like this, we got a list of all the actions. As we can see here in this shortcut, at least we see some parts of the action, like its name and shortcut, for example, and the state. Whereas if we invoke the command palette, which is another convenient way to access most of the actions in IDA, as well, we get to see more stuff of what makes an action. So the action will have a label, so that's the display name. It might have an icon, so as well, when we create programmatically an action, we can assign an icon. The action name, this is a short name. We can think of this like it's string identifier, so it should be unique. Optional hotkey and description as well. That's something that might pop up, for example, when we hover over a certain action and so on. So this is more of a descriptive text. That's like the label that we might see in the menus and so on. So these are the actions we see in the command palette, but what we see is contextual, and it's important to understand context. So actions, because they're highly related to UI components, actions will become available or not, or enabled or not, based on the current context. So what's a context? You can think of the context is the currently selected widget, so the UI element. So for example, here we're in the IDA view. That's the current context. If we are inside an action, then we know we can query or receive that information that we are in the IDA view. So IDA view is context. We switch to another widget. Now we're in a different context. And so like this, we'll see programmatically that when we switch widgets, we might get a chance for our action to decide whether our action is applicable in that context or not. Even here in the CLI output window or even CLI, if we invoke an action, the context will be this. So when the action is invoked, we will receive UI context related to the invocation point where we invoke that action. So we have seen two ways to enumerate the actions using the UI, either via the command palette, which will filter the actions that are applicable when we invoked it. So for example, if I'm in IDA view and invoke the command palette, I have 357 applicable actions in the IDA view context. But let's say we are in the classical structure view, for example, and if we go over command palette, we have less applicable actions because the context is different. So how can we get those actions programmatically? Now let's hop into the SDK. We open kernel.hpp, and one of the easiest way to approach that topic is let's just list all the registered actions. So we can call this to give us all the actions, disregarding whether the context is right or wrong. So like we did the command palette, we'll filter out only applicable actions. Here we get all the registered actions. And like this, we can see the totality of all the actions. So here, let's say I type x equal, and then we say get registered actions. And if we dump the actions, for example, we have all those actions, and let's see how many of them. So we have in my system, of course, I have different plugins, so I have 685 actions. Now one thing to notice is if we look at certain action names, let's pop the command palette again, and we see here the action name, that's the programmatic name. You can see the name is very simple, but then if we look down, for example, at the whole list of actions, we will see some actions that have like the plugin name, colon, and the action name. For example, here source debugger, colon, action name. And so this is a convention, as we will see, that we have to use as plugin writers or any add-on writer to IDA processor module, and so on. So this is the convention, and we can see that convention as well used by the decompiler, and it uses the hx colon prefix. So if I say hx, for example, these are the actions of the decompilers. Of course, as I said, command palette will filter out applicable actions. So there are way more actions for the decompiler. In fact, if we just simply decompile a function, go back to the command palette and filter. So for example, like this, I've seen all the actions that I can apply right now. But what I want to convey is the naming convention. And then now that we have an action list, for example, we can simply invoke the action programmatically as well. And so this takes us to the next function we can use before starting to create our own actions. We can use process UI action, and we give the action name. For example, let's see in the shortcuts here, let's suppose we have the functions window. So let me filter for functions, which is the shift F3, and the action name is open functions. So suppose we want to access any registered function programmatically, and of course this is going to be useful if you don't have a direct SDK function that gives you that UI functionality. So if you know there's an action that can do something, you can also use that as a way to programmatically invoke something. So if we say here process UI action and say open functions, so this will basically simulate hitting the shift F3 key. So let me just make sure I don't have the functions window open. So I'm going to simply run that command. And here the functions window got invoked. Now why did that work? Because the function window apparently is context agnostic. Anywhere in IDA, no matter what window you're open, of course, if it's not a model dialog, you can open the functions window. It's not like conditional on something. You can always open the functions window, for example. And so like this, we invoke a function. So similarly, also we have debugger APIs. Suppose you want to simulate the UI code behind of starting a process, you can simply figure out the action name and invoke it programmatically. So now let's look at actions programmatically. So actions start with calling register action. Register action will introduce that action to the IDA UI system, and we have to pass an action descriptor, which is a simple structure containing a bunch of attributes that we have seen part of them graphically. So for example, the action programmatic name, which should follow the convention, which is mentioned as well in the documentation. So we have to say my plugin colon and action name, just to avoid action name collision or conflicts. And then the label, so that's what we see if it's in the menu and so on. So the action itself, that concept is not new. If you've programmed for Delphi before, we do have a TAction object, and the TAction, for example, if we look side by side, we have the action name, label, handler, we'll talk about that, shortcut, tooltips, icon, and so on. For example, here the caption is the label, and image index is the icon, and shortcuts. So here as well, we have shortcuts, and so on. So it's very similar to that concept. So the action will let us create that centralized action unrelated to any UI attachment. So it's not necessarily attached to a menu or anything. And then because we have that central action descriptor, we can then use the same action and its handler to display it in the menu, display it in a pop-up, attach it to a hotkey, and so on. So it's a way to not repeat the code, basically. So in the action descriptor, when we register it, we have to pass the name, label, action handler, shortcut, tooltip, and some flags. So what we've seen so far real quick is, okay, this is all the UI stuff. That's what we see. What about the code behind? So the code behind as well, we can attach that to the action by setting the handler instance, which inherits from action handler. The action handler, as we've seen, is a member of the action descriptor. So the action handler is responsible for the code part of the action object. And so here we have two important callbacks. We have the update, which helps us decide whether our action is applicable in that context or not. And so we have to make a decision whether that we want to enable or disable. So the update virtual methods will have a bunch of return values of type action state, and in general we have either to return enabled or disabled, but there are also different levels of what kind of enable or disable, which will influence how often the update method is called. We're going to talk about action state in a bit, but first let's see how we can decide whether the action should be enabled or disabled based on the context. So what's the update context? What's an action update context? We should guess that the action update context is a structure with a bundle of information. action. So let's follow it. So action update contexts is inheriting from action context base, not the issue. And let's see what we get when our update method is called. So let's just simply go to the data section here and see. We will receive a widget pointer. So the widget pointer is that opaque object representing the UI element. There are other methods in KernWin that we can pass a widget pointer to get some information or act upon the widget. For example, we can call close widget and we will programmatically close a widget given the pointer. We get widget type. This is very important and very convenient as well. It's a fast way to determine if we are in one of the built-in UI elements or widget types. So in the update context, we will receive the widget type. We can query it. We can tell if we are in the exports window, strings window, and any of the multitude of IDA's built-in widgets. Like this, if our update handler is called, we will get an update context. We can query the type and decide my action should only work in IDA view or in the decompiler view and so on. So this is important, the widget type. Let's go back to see. As well, we can receive the widget title. So this is nice as well. We can just simply get it, or we can also call widget title. We pass the widget pointer, but we have it, so we can save one API call. As well, if the context is a chooser widget, so for example, functions window and so on, then when we get that update context, we also receive the chooser selection. So as well, from our update, we can see if there is any selection at all, chooser underscore selection dot size is 0, no selection, and so on. We get the indices of the chooser. So as well, we can tell what is selected if we want and query the chooser accordingly. We can also receive the programmatic action name in the update context. So we can have an action handler and the action itself, or we have 10 actions. We can use the same action handler and we can decide in the action handler which action it is by querying the name, for example. So that's kind of like multifunctional action handler. We will also conveniently receive, if applicable, the current EA. So if we're in IDA view, it makes sense. Hex view, it makes sense. Whatever views that have an address, we will get the current address. As well, if there is value under the positioned cursor, we will also get the function pointer, function chunk. If we're in the structure, we get the current structure pointer, member, enum member, what segment as well. All depends on the current context. And here, all those things are available to us. So this is the update. So we'll query the update context and then decide what to return. So now let's look at the action state real quick. So the action state, which is returned by the update, is responsible to tell IDA whether that action is enabled or not. And so if we return AST enabled, so action state enable, this is the least, I would say, optimal return value, because that means your update handler will be called every time something changes in the UI, a user moves the cursor and so on. So maybe this is too much. Unless your action is very dynamic that requires to track all the changes and like the update to be called, then you return AST enable. Like this, IDA will keep calling your updates when stuff changes. But if you want to enable your action for a given widget, so update will be called, you receive a context, you then query that update context and you say, okay, the widget type is the disassembly view. So that's it. I'm gonna be enabled. Don't call update. I made up my mind. I want to be enabled all the time for that widget. So when we return AST enable for widget, then we will get the update once. And then unless we change focus or change context, it won't be called. Once we change focus, then IDA will give us another chance, calling our update callback to decide whether this is the right context or not. Enable for IDB, different story. Simply, I made the decision on the database level, enable this action once and for all during that database. Enable always, where you don't care about the context at all. So IDA will call you once, you return always enable, and you will never be called to be updated again to tell IDA, you know what, I want to be disabled. So you can choose one of those. And also same for those for the disabled values. So you can make a decision on the spot. AST disabled, you'll be called each time. Then for widget, you say, you know, I don't want to work with this widget. Don't ask me again, and so on. So this is the action state returned by the update. Now, what happens when we invoke that action? So, for example, process UI action, or simply invoke it from a hotkey or wherever it's attached visually on the menu, pop-up menu, and so on. So that's where we put the code behind. That's the handler, what we'll be doing when we invoke that action. Same story, we override that method and implement the code, but as well we need context. So as well we receive context, which is similar to the update context, that gives us the information we just covered. So if we go to the activation context, which is an alias to the same type, so update context and activate context for now are using the same activation context or action context. So same story, you're now activated, you can query the widget, the current AA, and so on. Then, like the update, which returns the action state, activate as well can return some values. Now here is not very clear in the SDK. What does it mean if we return a zero value? From observation, it seems that the IDA UI treats a return value of 0 as a failure. Also here it says non-zero, all IDA windows will be refreshed. One would think that if you return a 0, that means no IDA windows will be refreshed, but it's very ambiguous, and so let's just think of it as true or false for now. So this covers all of the action related APIs to register and have a proper action handler as well. So that's the register action. And we have to unregister as well at the end. So maybe in the plugin initialization or constructor, and then in the destructor we do unregister. Now there are macros that help us create those actions, because there are some members I didn't mention explicitly, is the owner, for example, which will be telling IDA what to do on our behalf. For example, if we pass an owner, then we can pass the responsibility to IDA to take care of the action as well. So let's jump into the code and look at how we can use it practically. So what I have here is a very simple plugin. So the usual plug mode, my plugin here, and all I do in my plugin is simply register an action, and instead of directly passing an action descriptor, I'm using a simple macro, and that macro will fill in the owner for me. And so this is convenient. So if we know that our action owner within the plugin that we wrote, our plugin module, then we can use that macro. So that macro will create that action descriptor for us. It will pass the name, label, handler, and so on, but it will also pass the proper flags for the action here, and also we are passing this to the owner. So we're telling that this action is owned by our plugin. So here, this is the action name. I'm following the naming convention, my plugin name, and one of the actions, the label, the action handler. So here I have subclass the action handler and put some code in the activate and update. So for example here, let's close IDA. Here in the update, I can make that decision that my action should only be enabled based on that widget type. So this action will only work with this assembly view, for example. So if it's this assembly view, then enable for widget. So our update will be called once we make that decision. As long we are in the right context, we are still in the IDA view, we will not get the update. So our action will remain active. Then I put the code behind. So now that the action is enabled, then what happens if it's invoked? Here we receive the activation context, and I'm displaying the current EA. Now this will be a valid value because we are in the proper context that we filtered out in the update. So we know we're in this assembly view. So it is a valid concept to ask for the current EA, or even we can ask for the function. These are valid because we are in a disassembly view. Now, we might receive bad address. Maybe we run that action in an empty database. There's no addresses at all. Then we can get that bad address, for example. And we can receive a null function pointer in that action. So everything is possible. We still have to do some due diligence in the activation. So here in the activation, all I'm doing is simply making sure I have an address, and I'm adding a comment to wherever the user have that action invoked. So this is the action handlers, and in my plugin I just declare an instance and pass it, and that's where that basically the plug mode and the ownership. So that action handler now is the responsibility of the plugin. And here, because the action handler requires a pointer, so I'm telling it use my instance as opposed to creating one on the fly using new and so on and so on. Now we are not going to cover what we can do the actions to attach them visually. So for now, my action can be accessed either by the hotkey or simply knowing its programmatic name and invoking it. So even if I don't pass any hotkey, and just before we continue, and I'm gonna unregister the action. So let me run it. And so if we run that, there will be no visual indications at all, except of course for the action name. So here, this is the action name, and it won't be visible to us in the command palette until it is in the right context. So here I'm I'm in IDA view, Control Shift P, and just filter for that action, and this is my action. And the only way right now to invoke that action is by process UI. So, and this gives me a chance as well to demonstrate something subtle a bit. So look at that. So I'm gonna be invoking that action. Now when I invoke it, the context is the CLI. So the update method will return false. Don't enable for this widget. This will fail. Nothing will happen. So practically speaking, because we are invoking through the UI, how can I inject that method and still stay within the same context? So that's a bit tricky. So let's go back and just re-enable the hotkey. And so like this, if I'm in IDA view, enable the hotkey, I'm in the right context. So now if I press Ctrl Alt E, and here we see the action, it knows the address and it says set. Basically set, just I set the comment. That's what I asked it to do here. And so that's the gist of it. Now, before we show you the Python code, if you wanted to have multiple actions, what do you do? So for multiple actions, we'll have to register multiple descriptors and also multiple action handlers. And we can see that, for example, in the ugraph plugin example, where we have a bunch of different actions. And here in the plugin, we can see that plugin code is registering different actions and different action handlers. So this is one action handler, which is backed by its own class. Then we have another action, which is called the increment level, which has as well its own action handler here, and it will also inherit from its own action handler. So we see lots of action handler classes. It's really not necessary. In the future, show you some frameworks where we can simplify this verbose code, because if you want to have 10 actions, we're talking about 100 lines of code at least, and really it's not necessary. Alright, so now let's jump to Python. Python is simple as well, but the same concepts apply. So I'm just gonna quickly go over this. Here, this is not the proper way to do this in production, of course. This is the way I wrote it here. Using that concept, you can see previous videos about productivity in IDAPython and so on. We are using this just to let us rerun that script, and every time I run it, it makes sure it unregisters the action beforehand. So the first time we run it, there's no action, so there's no variable like that. And subsequent runs will make sure we unregister before registering. So here in this snippet as well, same story. Register action, we create the action descriptor, action name, label, the action handler instance with its own activate and update. Here I decided to do always enable. Of course, you can still say if context.widget type and so on. And you can decide based on the widget type, of course, the same logic, and same for activate and so on, and just simply register the action. If I run this script, it will register the action. So just run that script, and here action registered, and now that action was made to be always enabled, and this is the action name. So if I open, for example, command palette and just search for it, this is the action. Or I could have invoked it with the hotkey, so Ctrl Alt R, and this is the code coming from Python. Alright, so that's it for today. What we covered is the concepts of actions, action handlers, how to register them, and how they work with IDA when the context change and so on. We also covered IDAPython and how to work with actions equally. Now what we'll do in the future is attach those actions to more UI components. So for now we are invoking them with a hotkey as they're not visible clearly. Later, for example, we can say attach action to menu, or with the help of other UI hooks, we can attach those actions to a pop-up menu and so on. So this will give us real nice flexibility where we can extend IDA, hook up our code nicely and dynamically within the IDA UI. All right, thank you and see you next time.